Hello, welcome to another episode of our series focused on using GeoGebra in teaching mathematics, statistics, or related fields. In this particular session, we are going to explore a particular tool in GeoGebra called the slider. So let's go ahead and open our GeoGebra. The slider tool is of course found along our toolboxes listed in our toolbar. So if we can see this one, this is our toolbox containing our slider. So this is just the focus of this demonstration. So before I explain to you what a slider is, let us just create first one slider. So we click on this tool and then click anywhere in our graphic view. It will give us this pop-up menu. We can name our slider any letter, but by default it will start with letter A. We can choose among number, angle, and integer. That depends on what we need. If our slider covers any real number, then we choose numbers. If we are under trigonometric functions, or it involves at least our trigonometric functions, we choose angle, or if we are only considering the integers, then we click integers. We can specify the minimum and the maximum value of our slider. So by default it's -5. Just to show you that we can change it, let's change it to -10 and 10, corresponding to the minimum and the maximum value of our slider. Increment means the difference between any two consecutive number in our slider. So if we want it to be small, that is possible. Suppose it's 0.1. If we choose integer, of course, the increment will be 1. So anyway, let's just click this one so that we would have an idea of what a slider is. So we have a representation of it in our input bar. We also have one in our graphic view. So we can actually manipulate our slider in any view. Either we change it here or there. So what is a slider? A slider is a representation of a free number in GeoGebra. We primarily use a slider when we want to show the relationship of the graph of some function or relation with some parameters. So that is the reason why I am focusing this entire presentation with this particular tool, our slider. So if we move the slider to the leftmost, it will give us a value of -10 because we assigned our minimum value to be -10. Likewise, if we move our slider to the rightmost side, it will give us a value of 10. So any two consecutive number here, for example 10 and the lesser number, that's 9.9, the difference is 0.1 because we assigned a while back that the increment is 0.1. We can change our maximum value or minimum value here. We simply double click it here and it will allow us to change our minimum and maximum value, even our increment. So increment is just the same as our step. Have this one, we can organize our slider in our graphic view by selecting the slider and then moving to wherever we want our slider to be. Okay, so the next part of this presentation is to apply where can we use our slider in teaching our students in a particular lesson. So I have actually prepared some functions here. Suppose we are going to teach the functions or some dimensions of it, some part of it, using this particular tool. So actually, beside me, I've written already what we need, what we want to graph. So we can see here our trigonometric functions. I have written also their general form. So for example, f of x is a sine function of the form a sine bx plus c plus d. So this is the most general form of our sine function. We also have a general form for the cosine function and our tangent function. And suppose that in a particular lesson, we want our students to understand what we mean by A, B, C, and D, and what are their roles, how does it affect the function in terms of their graph. So that the students would understand what happens to the function if we, for example, change A, if we change B, if we change C, and D. So we can use our sliders to do that. So we create sliders for A, for B, for C, and D, and then later on, we can graph the function using our sliders. So let's do that. Since I have already A here, I'm going to create a slider for B, C, and D. So let us grab our slider tool, create one. It's automatically named B. Let me do the same. Our minimum is -10, maximum is +10, and the increment is 0.1. Of course, we can make it smaller, 0.01, 0.001, whatever. We also need a slider for the parameter C. It's automatically named, just a little tweak on the maximum and the minimum value, also the increment. And then we also need another one for D. And then the increment is still 0.1. Alright. Anyway, if we do not want our slider to show in our graphic view, we want to manipulate them in our input bar, we can actually hide them by clicking this one. So we can hide it here so that it will only show here. Anyway, let me bring it back, unhide them. Okay, so we have here our 4 sliders. We need 4 because in the general form of our trigonometric function, we have 4 parameters, namely A, B, C, and D. Now, we want to show our students the roles of the different parameters. So let me encode the function as is. I've named them, actually. So for the sine function, I named them f. So f of x is equal to A times, so I am using now A times sine parenthesis bx plus c plus d. So here is our graph for this general form of a sine function. So it's really a cyclic function because it's a trigonometric function. Now, what is the use of our slider? Why did we choose to do this when we can actually input a specific number for A, for B, for C, and D? Notice this when I slide our sliders. For example, A, slider A, the graph will automatically change. Well, of course, this function will assume whatever the value that our slider is currently in. So if our A is -8.5, our function is -8.5 sine something, so that we can easily see the changes in our graph when we use this slider. A here in our general form is actually the amplitude or the height of our function. So it is obvious to the graph that we see here. We can also manipulate it here. How about B? What is the role of B, the parameter B in our function? So, well, B is actually something that has to do with the period of the function. So it compresses or stretches our graph horizontally. So there we have it. Anyway, I'm just demonstrating to you how we can use our sliders. But when we actually teach this subject, this concept, of course, we have to be slower for our students. C is actually a horizontal shift. It shifts the graph horizontally. So if we set this equal to 0, it crosses the origin. But if we change the value of C to a non-zero number, it shifts. It moves to where? It moves to the left if it's positive and to the right if it's negative. So that is what we mean by horizontal shift. If D is 0, we have the original function a while back. But if we move D, this parameter, it shifts the graph vertically. So it's just changing the location of the graph, but it's actually the same graph. So this is how we use the slider. For teachers who are also creating a material but involves a lot of the same function but different functions, for example, different values of A, B, C, and D, we can actually use this one so that we do not have to be encoding our function every time. So we can just set the desired value of A and then save what is this? Save our graphic view as an image file. Let us also graph the other trigonometric functions, but the idea is just the same. A times, by the way, when we use this one, A times something, A times cosine or A times tangent, we have to make use of the operation dot. This is a dot, asterisk in our keyboard, and we do not just simply encode A sine bx, because A sine bx will be interpreted by GeoGebra as inverse trigonometric function. So A cosine bx plus C plus D. Let me do it as well for our tangent function. That is h of x equals A times tangent bx plus C, and of course plus. So these are our major or primer, these are our basic trigonometric functions, the first three. Let me hide first the sine function since we have investigated that one a while back. So let's focus on our cosine function. So if we let everything 0, let's make C equal to 0 so that we can have a starting point. Well, can we make B equal to 0? What happens if we make it 0? It just becomes a vertical line. Well, so suppose B is 1 and A is actually any number. So it's just the same. A here is the amplitude of the cosine function, so it just changes the height of the function, of the graph of the function. But the function is actually the same in terms of its roots, where does it crosses the x-axis. C here is again a horizontal shift. It shifts the graph horizontally, and D shifts the graph vertically. For our tangent function, what happens? If we move D, yeah, it's moving vertically. C, it's moving horizontally. And if it's A, it's actually just the same, but it compresses and stretches the graph. How about B? It changes the period. So period means the distance between two consecutive cycles. That is one example of using our sliders to teach a specific topic in mathematics. Let us continue with our different conic sections. Let us graph our parabola, circle, ellipse, or hyperbola using a slider. So we can see here in the board, this board beside me, I have written already their general form, or I mean the standard form of our conic sections. So in our conic sections, it involves different parameters. We have a, but we have h and k. So h and k here for a parabola means the vertex. It represents the vertices or the vertex of a parabola. For a circle, h and k is the center. And of course, we have r, that's the radius of the circle. For our ellipse and hyperbola, we have our h and k. It's the center. Those numbers here, a and b, represents the length of a minor and a major axis for an ellipse. And same through with a hyperbola. So we need h, k, r, and what else? Because we already have a slider for a and b. So we need h, k, and r. So that's what we're going to do. Let us have an additional slider. So let me remove first the slider c and d and add, no, it's here, add a slider for h, another one for k, and of course the radius of a circle r. So let's name it r. R can be any real number, so we can have it here. 0.1 is still the increment. Okay, so we are now ready. Maybe I can put it here so it won't be crowded there. Okay, let us now encode the general forms of a parabola. Y minus k equals a x minus h quantity squared. So there is my parabola. So what happens to the parabola if a is increased or decreased? The parabola widens. So if a is positive, it is actually opening upwards. That is easily seen here. But if we make our a negative, the parabola opens downwards. So the students can now realize that changing the sign of a simply changes the opening of a parabola. If h is changed, well, of course, it shifts the parabola horizontally, because again, h and k here represents our vertex. So if we want to change the vertex of the parabola horizontally and vertically, we can slide our h and k sliders there. So for k, it changes the vertex of the parabola, specifically the y coordinate of our vertex. What else do we have here? We have a circle. Let me hide first our parabola. All right, let's encode our circle. X minus h quantity squared plus y minus k quantity squared equals r squared. So we have our circle here. It's here. Now, if we change, of course, the radius, the circle changes. We are increasing it, so the circle becomes bigger. The radius is higher. Well, of course, the radius cannot be negative. So we can actually edit our r here for the slider. Since it cannot be negative because it's a distance, we can set this one as, say, 0.1. It can't even be 0 because the circle becomes a point. So there we have it, our circle. Similar with our h and k here, it just moves the circle horizontally and vertically. So if we make it 0, or 0, I'd like my circle exactly at the origin. So that means the center should be at 0, 0. The value of h and k should be 0, 0. Alright, so there we have it. The circle centered at our origin. Another one, ellipse and hyperbola. We have x minus h. Let me encode it faster. Okay, there we have it, our ellipse and hyperbola, but can we see an ellipse here? Well, of course, we have to do something with our slider. We need to adjust. So there we have it. If A is increased, our major axis for this ellipse is elongated, becomes longer. This is our major, or I mean minor axis. So if A is greater than B, we see that the major axis is parallel to the x-axis. If we make B greater than A, the major axis of our ellipse is parallel to the y-axis. H and K here simply moves the ellipse horizontally or vertically. So it's actually consistent with any of our conic sections. If we want to create our hyperbola, we can actually edit our function, because the form for an ellipse in a hyperbola is almost similar except for the sign here. So we make this subtraction, we can actually form our hyperbola. There we have it, our hyperbola. So this is how the different parameters affect our hyperbola. Of course, it doesn't involve R. H and K simply shifts our graph horizontally and vertically. So those are our different conic sections. We have our last function here. It is our radical function, a very simple radical function, nth root of x. Nth root of x is just the same as x raised to 1 over n. So let us illustrate or demonstrate the graph if n changes. So we have another slider, it's n. So let's hide our sliders here because we only need one. It's n and it's not yet created. So let's do that. Create a slider for n. Well, for a radical function, n here, the index is an integer that starts from 2. Cannot be 1. And then let's make our maximum value 15. And of course, since we choose integer, because the index should be an integer. Okay, so we only have one slider here. Let's now type our function y equal to x. As I have said a while back, it's just the same as x raised to 1 over n. No, it's n. Alright. And then let us observe what happens to the graph of this radical function if we change the value of n by sliding our slider here. So there we have it. Let me put it higher. Okay, from n equal to 2, let us move towards the right so that it increases. It's n equal to 3 now. That's the graph. And then we have n equal to 4, n equal to 5, n equal to 6, n equal to 7, 8, 9, 10, 11, 12, 13. So what can we observe in the graph? We see that the graph changes depending on whether the value of n is an odd or an even integer. If it's even, we see that the function is undefined for negative numbers. That's why we do not see any part of the graph at the left part of our graphic view. If it's 4, we do not have anything here at the left. That's because, again, fourth root of x is undefined for negative numbers. So we can actually generalize this one by just merely looking at the graph for indices that are even numbers. For odd numbers, it is defined. So we can see the graph of cube root of x for any real numbers. That happens if n is odd. So if n is odd, nth root of x is defined for any real numbers. So this ends our presentation. I will see you in our next video. Thank you for listening.